Now we're at 5.6, number 5, where we have to decide if the inverse is a function. So to do that, graph this function and check the horizontal line test. Okay, so let's graph it. It is x to the third minus 1. X to the third minus 1. And you can see if we drew a horizontal line through this, it would only touch the curve in one point for every horizontal line that you could draw. So the inverse of f is a function. Yeah. And then we have to find the inverse. So this is y equals x to the third minus 1. So the inverse is x is y to the third minus 1. Solve for y. And then take the cube root. And y is the cube root of x plus 1. There it is. Now we want to find whether the inverse of this is a function. You can see already that this has an x squared, so it's going to be a parabola, opens up, shifted down 5. And this does not pass the horizontal line test, so we're going to get the inverse is not a function. But let's graph it just so we can see that that's the case. 2x squared minus 5. And the graph of it, parabola shifted down 5, opens upward. And you can see it does not pass the horizontal line test. So it is, the inverse is not a function. But we can find the inverse, right? This is y equals 2x squared minus 5. So the inverse is x equals 2y squared minus 5. Add 5. 2y squared is x plus 5. Divide by 2. Y squared is x plus 5 divided by 2. And then we need to get rid of the squared, so we square root both sides. Have to remember the plus or minus. And y is plus or minus the square root of x plus 5 all over 2. That's inside the radical. Okay? Hopefully that makes sense. And now let's do number 7 and 5, 6. We have to check to see if they're inverses. The way I like to do it is you grab the most simple one, find the inverse of that, and check to see if it's the same thing as the other one, right? So the inverse of this is x equals 2y minus 9, and you solve for y. 2y is x plus 9 divided by 2. Y is x plus 9 all over 2. You could write that as x over 2 plus 9 over 2, right? But that is not this. So these functions are not inverses. Right, there is chapter 5, and we're up to chapter 6. So that is good. We're almost to real time. Evaluate 2 to the x power, where x is negative 2. So 2 to the negative 2 power. And that's as simple as just grabbing your calculator and putting negative 2 as a power on 2. and that's 1/4. All right, you can find the fraction for that if you're interested under math, and then you can change it to frac and get 1/4. And now we do the same thing with 3. 2 to the third power is 2 times 2 times 2, which is 8. Okay, that's not so bad. Tell which function represents exponential growth or decay. So in this section, the way you distinguish between growth or decay is you look at the base. Since it's greater than 1, it does not look like the word man. It's growth. Right? Greater and growth will start with G's. Maybe that's how you remember. So this is growth. And growth goes up from left to right. This is decay. Cannot be that one. Growth goes up from left to right. This is decay. Cannot be that one. You can figure out usually which one it is by a couple of quick points. Like if x is 0, then we have 6 to the 0, which is 1. So it should go through the point 0, 1. They both do. If x is 1, it's 6 to the 1, which is the number 6. The point 1, 6. 1, 6 is there. That's not on it. 1, 6 is here. This is on it. So it's this. It's this bottom left choice is the one. Okay. So now the base is less than 1. So it's decay. And decay goes down left to right. So it's not this one. That is decay. This one is growth. That one's decay because it goes down left to right. We have to choose which one it is. This one's a little trickier. It might be a good idea to graph this. I'll do that in a second. When you plug 0 in, anything to the 0 power is 1. So it should go through the point 0, 1, and they both do. Now the trick with the fractions is you plug in -1. 1/6 to the -1 flips the fraction to get +6. So we're looking for the point -1/6. -1/6 is right on that line. This is the correct one. This one looks like it goes through -1/4, so it's not this one. Okay, so it's this choice. Let's graph that really quickly so you can see how that feels to graph it. So under y equals, we're going to change this to the fraction 1/6. Anytime you have a fraction on a calculator, put it in parentheses. We'll take that to the -1 power. Nope, I'm not going to take that to the -1 power. We're just going to put x there because it's 1/6 to the x power. And we're going to press graph and look at it. You're going to see its decay because it comes down, follows that x-axis. And then you would have to look at the table to see what the y value is when x is -1. And the y value is 6 when x is -1. So -1/6 is that point. Okay. All right. We have to decide if this is growth or decay. It looks like first. We can see the answer right there. It's a good idea to rewrite this. The principal is 200, and this is 1 minus 0.25. That's how you get 0.75. And the power is t. Since 0.75 is less than 1, it's decay. Now, what is the annual percent increase or decrease? Since it's decay, it's decrease. and it decreases 0.25, 25%. And when will the value of the bike be 50? So this is a tricky thing. Use your calculator to find it. We're going to put the function in 200 times 0.75, the power of t. We're also going to graph the horizontal line, y equals 50. And the trick is to see what t value, or x value in this case, what x value we need for those two lines to intersect. But in order to be able to see where they intersect, we need the y max to be, well, at least 50. I would like to go 60 or 55 or something. But now when we graph it, we'll see the line y equals 50 on the graph, and we'll also see the decay function. It's probably up here. Yep, there it is. And the x value where they intersect will give us the answer to this question. You can use second trace because that gives you 5, the intersection function. Just cursor over pretty close to the intersection spot. Looks like 1, 2, 3, 4, close to 4.5 or 5 or so. There. Now we're close to the intersection spot. Press enter 3 times, and that'll give us 4.811. And I think we rounded to nearest 10, so the answer is 4.8 years. Okay. And here is 6.1 again. Use the information, 6 years compounding quarterly. So here we need to know a specific formula. The formula is the final amount is the principal times 1 plus the rate divided by n, where n is the number of times you're compounding each year. This says compounded quarterly, so in this case, n is 4. And then we take it to a power, and the power is n times t, where t is the number of years. P is the principal, that's the amount you start with. So we can calculate this, right? We're going to get the final amount is 3,500 times 1 plus the rate, which is 2.16% as a decimal, divided by 4, because that's n, the number of times it's compounded each year, and the power is 4 times 6, because t is 6. You can plug that straight into your calculator and just let your calculator do all the thinking and figure out the order of operations and stuff. So 3,500, and then times 1 plus another fraction, put that in parentheses, 0.0216 divided by 4. And we need 2 parentheses now. And the power is going to be 4 times 6. I can just, oops, power 4 times 6. And you'll figure that out too. And there it is, 39, 82, 92. Make sure when you're giving an answer that's in money, you round to the nearest penny. It doesn't make sense to have tenths of pennies. Unless you're taking the AP exam, then you want 3 decimal places even with money. Okay, it looks like we're at 6.2. I will pause here and we'll finish the rest hopefully later on today or maybe tomorrow.